Okay, guys, here's number 2, starting with, what was it, question 5, right? Yeah. So, um, hmm, 2 questions for sine, 2 equations for sine, 2 equations for cosine. Let's get started. Let's just do black. So, sine, we'll do sine first. The 2 functions I will write for sine, I'll just pick 24 degrees first. So I can do the sine ratio, opposite head and hypotenuse, for 24. I can also do the sine ratio for 66. And sine 24, so opposite. Remember, sine is just simply the name for the ratio for the opposite over hypotenuse side. So that's y and 7, so y over 7. Sine for 66, though, I think this is tripping up a lot more people. I think more and more people are making sense of it as the unit goes on. But when we talk about sine being opposite and hypotenuse, it's really the most important thing is to make sure that you understand that you're picking an angle first. We refer to an angle as the reference angle. Before we can write the ratio for sine of an angle, we have to know what angle we're referring to. So the reference of 24 degrees means that once we've locked in 24 degrees as the angle we're working with, then we go across and we say that the y is the opposite and the 7 is the hypotenuse. And the reason that's so important is that when we come back and we focus on 66 degrees, when we look at the ratio, it's still going to be opposite over hypotenuse. Sine is always opposite over hypotenuse. The difference is when I look at and have picked 66 degrees over in this corner of the triangle, opposite is no longer y. Opposite is now the angle, go across from the angle, and we have x. So now sine of 66 is x over 7. The hypotenuse isn't going to change. The hypotenuse is designated as the longest side of the triangle. But when we were working with 24, the side opposite of that angle was y. For 66, the side opposite was x. It does also then say write up 2 equations for cosine. So we'll do that. This is fun purple. So now we'll just go like that and call this cosine of 20. No, actually, I'll be very intentional with this. I'm going to switch it and go 66 first. And cosine of 24 second. Because, now check this out. If I'm looking for the cosine, remember by definition, cosine is really just the placeholder for the table when you look at the ratio of the adjacent side over hypotenuse. So if I go to 66, so 66 right there, if I look at the adjacent side, adjacent by definition means next to. The side next to angle 66, well, there's y, but there is 7 at the same time. But remember, 7, in this case, that's our hypotenuse. We cannot call the hypotenuse anything but hypotenuse. We're going to call this other side next to 66 the adjacent side. So here, the adjacent over hypotenuse. And cosine of 24, okay, now let's focus on this as a reference angle. The side adjacent is x over hypotenuse is still 7. And hopefully you're starting to see this pattern. The sine of one angle, so in this case 24, the sine of 24 is going to give me the same decimal as the cosine of its complement. Complement meaning, right, the other angle that adds to 90. So, kind of cool, right? The sine of one angle is equal to the cosine of its complement. So, we're actually going to roll that into the next question because I hope that made sense, right? 2 equations inside. Okay, so you get to Desmos and the answer key. things start getting a little weird. And what I mean by that is, yes, question 1, cool snowman. Question 2 lined up. Question 3 even lined up. Question 4 and beyond, like this is question 5 on the answer key for Desmos, has nothing to do. This is actually question 5 here is actually for us on the paper copy is question 13. So I don't know if I'm going to be able to fix that or not. So just a heads up. If you keep going though, we do find question 7 on Desmos does in fact correspond to question 5 for us. So you are able to, I believe, like say, so sine of 24, that's y divided by 7. Let's see what happens. Incorrect. Okay, cosine 24 is x over 7. Sine 66. We'll see what happens here. Cos 66y. Okay, I give up. I'm not gonna lie, I'm a little frustrated by that. Anyways, with the numbering being off, so forget that. Well, let's go to number 6. Number 6 is asking us, hey, right triangle, one angle is 90. One of the acute angles is 6. What must the measure of the other acute angle be? Well, okay, so what work can I show? I don't know. I mean, all the angles have to add to 180. So I've got a 90-degree corner because I'm a right triangle. I was told I have a 6-degree angle. So that leaves me with 84 degrees. So that, there's nothing more to say about it, right? The 3 angles add to 180. One of them is a 90. They tell us the other one's 6. The other one must be 84. What do you know about the unmarked angle for number 7? Okay, this is where we get kind of theoretical. What I mean by that is we're not going to call like this angle down here. We're not going to call this theta and this is called alpha, right? Because that's another angle symbol that we'll use coming up. Right, we don't call that alpha. What we know it to be is 90 minus theta. Right, so what do we know about the unmarked angle? The unmarked angle has to add with theta so like theta plus we had at one point. Let me change that real quick. Back. We had called it alpha. So theta plus alpha, we know together must equal 90 degrees. Because 180 total, 90 down here. So 90 minus theta gets us this alpha corner. So really alpha is equal to 90 minus theta. So I don't know what the answer key would say about that, but the reference is always, we're looking for theta and 90 minus theta, or x and 90 minus x. It doesn't have to be theta per se, but that's where we're at with that. So, all right, let's keep rolling. We got time. Question 8, based on the figure, circle each statement as true or false. Okay, well, cosine of 42. First of all, we have to figure out which one is 42. Well, here it is. Because remember, 48 plus angle B must equal 90, so there's your 42. Given angle 42 is in that top corner, B over C. Okay. Cosine is adjacent, so the cosine of 42 would be referring to the adjacent and hypotenuse sides. Well, that would be A over C, so it's not A. That would be false. Cosine of 48. Okay, well, here's 48. I'm going to change color again. 48's cosine, that's adjacent over hypotenuse. Well, that's B over C, so yeah, that's true. Sine of 42, sine, let's just keep rolling here. Sine of 42 is opposite, so B over C, which, yeah, checks out. That's what they're asking for. Sine of 48. Okay, well, let me get a little messy up here. There we go. New color. Beautiful color. Look at that. Sine of 48, opposite A over hypotenuse C. That is false because they are calling it B over C. Don't know what else to tell you about that. It's just about calling out sides based on the angles. So know which angle you're looking at. Find the angle on the triangle. So I'm up here for 42. 42, I know that I need the adjacent because cosine is adjacent to hypotenuse. Adjacent is next to. Next to is, in this case, A. All right, and then you just keep rolling through all of that. Yeah, let's do one more. We got time. Okay, number 9. Select all true statements. Explain or show your work. Okay. What they're trying to do... A triangle for each situation. Woof. Okay. I will do the first one or two, and let's see if that's enough. The first one, here we have... I'm going to call that 23 degrees. That's 90. Well, then that means that this upper corner here, that must be 90, 67. Okay, so that checks out. 23 and 67, those are complementary. So if I look at the angle 23 down in this corner, and I set up the ratio as 14 opposite, right? That's the opposite side, over the hypotenuse, 14 over y. It's asking if my ratio is 14 over y for this guy, sine opposite hypotenuse, then does that mean that the cosine of 67, so now I got to go back to the upper corner here. My cosine is looking for the adjacent side. So up here, my adjacent side is that vertical leg. So is that same ratio 14 over y true? And yes, so that is a true statement. I'll do another one. We'll go red this time. I've got 46 here. So that means this guy's 44. And it says the cosine 46. Okay, so pick my corner, 46. Within 46, I have to look at the adjacent side because I'm working with cosine. Cosine 46 is x on the adjacent side, the side next to me, over 5 on the hypotenuse. Is it true then that the tangent of 44 is x over 5? The tangent of 44 would be looking for this side, the opposite x. It would be looking for x over opposite over adjacent, x over y. So no, that is not true. See, so you would be able to make a lot more room, hopefully, on your sheet there. But that's what you're doing, right? You're setting up triangles and saying, hey, I need to determine whether or not the ratio from one reference corner is equal to the other. Wow, 89? Are you kidding me? 89? That doesn't even make sense. Look at this. Does 89 plus 11 get me 90? No, I'm not even going to waste any time on letter C. 89 and 11 have nothing in common. They're not complementary. They're not supplementary. It's just a bogus question. So 45, here we go. 45. That's a valid 45, which means that's 45. Okay, well, if sine of 45, here's, this is a little tricky. Sine of 45, pick my angle. Well, do I pick this 45 or this 45? The answer is, it doesn't matter. I'm going to pick one and just call it 4 over b. And then I'm going to look for the cosine of that. And so that's 4 and that's b. I only have 30 seconds here, so before the video cuts off. The bottom line is, if I have 45 and 45, then my sine and cosine are in fact the same value, because whether I'm looking at 4 over here, I know that this has to be 4 on this side because they're equal angles, they're the equal length. So anyways, 5 seconds left. I will see you in the next video for the next set of questions.